Hello everyone, and thank you very much for joining in lesson number 20 of the Java Fundamentals stream. If you are watching the event live, don't forget that you have a live chat there so you can ask questions directly in the live chat, and if you see the video afterwards you can still ask questions in the comments section, or you can find me on LinkedIn or Twitter and you can ask me questions there, and I will create either a separate video for you or I will answer you in the next lesson. This lesson number 20 is about Lambda expressions and enums. So in the past couple of lessons we have discussed about interfaces, a lot of details about interfaces, and some of the examples refer to functional interfaces. And it was for today when we have to discuss about Lambda expressions and all the syntaxes related to how to write Lambda expressions in Java. So I will start with the first example. I will create a new package. I have here already created a project using version 13 of Java, and then let's create a new package, example 1. And in this package, of course, we will create an interface. A Lambda expression is actually a syntax that is written based on an interface, and that interface has to respect some specific rules. It's named the functional interface, and it has to have one abstract method and one and only one abstract method. So it can't have less than one, it can't have more than one abstract methods. It can have multiple methods, but only one should be abstract. So this is the rule. I think we have discussed about it also in the previous lesson, but I want to remind you, and we will see how to create now this kind of a functional interface. So I will just start by creating this interface, and let's call it play. Let's call it, this is actually an instrument, a musical instrument, and play is the method in the interface. So in order to be an interface, of course, that means that we will use the interface keyword for the declaration, and then we have void play, which is the name of the method. In my case, very simple, it just doesn't return anything and it receives no parameters. The name of the method is play. And you already know that in order to create instances that can be assigned to this type, you have to create a class, and that class has to implement the interface and override the method. But that's sometimes too heavy to do. So when you only have such an operation, so it's a contract that only defines one abstract operation and only one, then you could only easier define it with a Lambda expression. So let's see how to do it in a class that I will call example1, and here I will have the main method. And again, you know that I would be able to say I is, and then I would of course need a type that implement the interface and override the method. So let's consider that would be piano or guitar, doesn't matter. We don't have such a type here, but we want to provide an implementation for the only abstract method that we have in this interface. So in this case, we will actually have the syntax of the Lambda expression that uses an operator written like an arrow formed of a dash and the greater than symbol. And then just before this operator, you will have the parameters of the method, of the abstract method, in the instrument interface, which is the contract for which I implement the method. And then of course you will have the implementation of the method here that can be either written as one instruction, or if you have multiple, you can put them in a block very similar to the block of an implemented method, and that will be between the curly braces. So you can write something like this directly. For example, if I want just to print something, then I can print something in the console, and I can avoid to write the curly braces if this is my only instruction in the block of the Lambda expression. So this is it basically, because this is an implementation. Now you can consider that here we actually have an instance. It is just a normal instance of a type. It is in this case an anonymous type because we didn't specify any method. It's defined by the lambda expression. We will get a lot deeper into nested types, into anonymous types, when we discuss about the nested types chapter in one of the future lessons. But for now, you can just imagine that it's basically like you have an instance of a class, and we can call it an anonymous instance because the class doesn't have a name. It's just this lambda expression here. And we have used this syntax because it's a shorter way. You don't have to define a class. Maybe in the case you only need an instance, then of course it's much easier just to represent it through the lambda syntax instead of writing an entire class that implements the interface just to create then only one instance of that class. So in this case, we can simply just specify the implementation via this very simple syntax. So we call this a lambda expression. Again, this is the first example. Let's see now how you use it. So you have I, and you know that I actually now contains the instance of the implementation. You can just call the play method. You know the contract has the play method, and you also know that the play method actually does exactly what is in the right side of the arrow symbol of the lambda expression. So this is basically referring to the implementation of the play method in the instrument interface. And that's why basically you can only do that for an interface that has one and only one abstract method. It can't have no abstract methods, and it can't have more than one, because otherwise it would be ambiguous and you would not know who is actually the method that you overwrite. So that's why the definition of a functional interface is an interface that has one abstract method and only one, and only by a functional interface you can write a lambda expression, as you see in my case. So then this now contains the instance, play method can be called, and of course each time we are calling the play method we will see exactly what we have specified at the right side of the arrow of the lambda expression. So by calling the play here, we will see the smiley face appearing in the console. I have just run the application, so let's wait a little bit for it to compile and to see the console. And indeed we have called the play method, and we have seen exactly the system out from the right side of the lambda expression. Now, if I'm going back to the instrument interface, then if I try to remove this method, and at this moment I have no methods in my interface, then you will see that the syntax of the lambda expression fails. So that's of course expected, because you have to have one abstract method. If, for example, I will put back the play, but then I will call it as a default implementation, and you know that starting with Java 8 we are able to provide default implementations for methods. So you just use the default keyword, and then you can use the curly braces to surround the a default implementation of the method in the interface. Then you go back to the example and you see that again this is still failing. So it doesn't matter if you have one method, it has to be abstract. So if it's not abstract, then it's not a functional interface, and then you can't write a lambda expression over it. So that's important. So I'm going back and make it abstract again, and when I make it abstract, then I'm having again a code that compiles. If I'm writing one more abstract method, then again it is a problem. You can't have more than one abstract operations, so it would be ambiguous. You don't know in this case which is the method that you override. So we syntax a syntax for the functional interface forces that you have only one abstract method. But of course, then if you want to have multiple methods in which some of them are default or static, you could do that. So in this case, as you can see, this is compiling. My interface has multiple methods, but as long as only one of them is abstract and you have an abstract method, then it is a functional interface. and you can write a Lambda expression for that interface, like it happens in my case. So this interface now indeed has two methods, but one and only one is abstract. So this is the method that will be overwritten when you write the syntax of a Lambda expression. Otherwise, you can then just add as many functions as you want, static or default. So again, I can even have static functions and it still works. So you just define, and as long as you have only one abstract method, then you will be able to use it as a functional interface. So this is the definition of the functional interface. You can use it as you can see here, and there is one more thing to be taken into consideration. When you want to write a functional interface, if you want to consider it a functional interface that will forever remain functional, it is always better that you use the functional interface annotation. This annotation doesn't make your interface functional. So your interface is functional in terms of the language as long as you have one function, only one abstract method. You have one abstract method and only one. But this forces the compilation of the interface itself only if it respects this rule. So if I would try to make this now abstract, then the entire interface would not compile anymore because of the functional interface annotation here. It's very similar, it works very similar as the at override annotation. So when you were using at override annotation on a method, you were specifying that you would like that method to be overriding something, and if something was changed, for example in the parent class, and the method didn't or became something else like an overloading instead of an overriding, then the annotation would not compile anymore. So it's somehow caution rule that you want to mark this interface as being functional, so it will compile, and this will compile only as long as you have a functional interface. And now again, using the functional interface, you force the interface to compile or not, so you don't get to use the Lambda expression that fails. So one of my recommendations would be, you will see in libraries or frameworks sometimes interfaces that have only one abstract method. Then of course, if they do so, you will be able to use them in Lambda expressions. But be very careful with this kind of interfaces in libraries or frameworks, because they might not guarantee you that in future versions of the same framework or library you will actually have a functional interface. So as long as this interface doesn't is not marked as functional explicitly using the functional interface annotation, and you are using it as a functional interface, then there is also the possibility that you will use it as a Lambda expression, but in one of the future versions of the library or framework that you are using, somebody adds one more abstract method to that contract, or change it somehow. Maybe it makes the abstract method a default method, I don't know, just use it as default and then does something here. And of course in this case, as you can see, it's not functional anymore, and it will not work anymore in terms of writing Lambda expressions. But if it was marked as functional, then the one who did the interface and marked it as functional interface somehow assures that in the future it will remain functional. So again, the recommendation is use Lambda expressions for interfaces that were marked as functional. If an interface has one abstract method but it wasn't marked as functional, then preferably don't use it in Lambda expressions, because that might be that in a future a version of that framework or library you are using, somebody could change that. As long as it is not marked as functional interface explicitly using the annotation, it means that you still have the chance that it can be changed and the interface can become non-functional. So then Lambda expressions cannot be written anymore on them. Okay, if this is clear, let's now go and discuss more syntaxes on writing the Lambda expressions themselves in the next examples. So I will close this example and I will create another one example too. And I will just create here an interface X. Well, I don't really care that much what this X is or what it does. I only care here about the syntaxes. So I just want to show you what happens when you have a return type, when you have parameters, and all the possibilities in which you can see Lambda expressions. This is basically very important when you are going to your OCP 11 exam. So when you are attending the exam, before that, make sure that you know all the possible syntaxes for Lambda expressions with methods having 0 or more parameters, with or without the return type. You will see there are some rules. I will try to specify all these rules here for you, and then you will have to remember them before going to the exam, because you will have plenty of questions that test this knowledge. So let's say for the moment we are keeping our method being void, and then I will only focus on parameters, because we have already seen what happens when we have no parameters. This time I will add one parameter to my method, and let's see how can we override this. In the main method, let's use something else than X, just that we can't have two variables of the same type. So we can write something like this. And as you can see, a little bit different here from the previous example is that in the previous example I have used the round parentheses here, and I cannot miss them if I don't have any parameters. So I have to use them. If I don't have any parameters, I have to put the round parentheses to mark these are the parameters of the method, so actually that the method has no parameters. But if I have one parameter, then I can avoid using the round parentheses, or I can use them. And I can even use them with the type itself. So you could write something like this. And also be very attentive with the var word, as the var word can be used in Lambda expressions starting with version 10. I think it was implemented. Actually, it was version 11 for Lambda expression. Var appeared in version 10, but in Lambda expression starting with version 11 you can use it. It's still part of your OCP 11 exam. You won't see this kind of syntax if you are attending the OCP 8 exam, of course. But if you are attending the OCP 11 exam, then you might have the chance to spot the var word being used in the Lambda expression, and you have to know that this is possible. And starting with version 11, you see it's possible. Of course, I'm using 13 here, so I'm also able to write the var word as you can see it. So here, as you can see, I just focus on the left side of the Lambda expression, and you can see when I have again no parameters, I have to use the round parentheses. I have no other option to specify there are no parameters than use the empty round parentheses. But when I have one parameter, I can use either the name of the parameter, which in my case it was X here, so mind that
it doesn't matter how it's named inside the interface. You can name it anyhow here. You can call it W if you want. Doesn't really matter. Just use it afterwards, of course, inside the block of the implementation, you will have to use it as you have named it here. You can use the round parentheses as well. You can use the type, and again with version 11 you can use the var word. So these are the syntaxes that you will see in the left side. Let's see what happens now if you have an interface Y where you have more than one parameter. So I will create an interface Y, interface, and then I will just create another M method, and I will have two different parameters. They don't have to be of the same type, of course, just this is just in my example, but you can have different types, and you will be able to use a lambda expression for it, but then you have to use the round parentheses again. So there is no chance of avoiding writing the round parentheses if you either have no parameters or you have more than one. So the only case in which you avoid the round parentheses if you have only one parameter. Then you can avoid writing anything. You just write the name of the parameter and that's it. But if you have more than one or less than one, you have to use the round parentheses, and this is the way it works. And again, you can use the types. Of course, be attentive. If you use the types, you have to use the type for both of the parameters, so you can just use the type for the first and avoid it for the second. You have to put for both of them. And there is a possibility, of course, starting with version 11 to use the var word. So the same thing, if you want, you can replace with var. You either replace for all of them, either not use it at all. You can't use it only for one of the parameters. So these are the syntaxes that you should know. And again, you have seen now the syntaxes of writing parameters for lambda expressions, for what happens when you have no parameters, what happens when you have one parameter, and what happens when you have multiple parameters. These are the syntaxes in terms of writing parameters that you have to remember. Usually in practice, you will use probably the simplest, so it would be either this one for the case of one parameter, either this one if you have more than one parameter where you don't specify the type, and if you would only if you would like to use annotations on parameters, then you either have to use the one with the type or the one with the var, and the var word is used to replace long names. So basically you won't use var instead of int, because basically it has the same number of letters, so you didn't do you didn't do anything in this case. You didn't shorten anything. But if you have a longer name, then you might find it comfortable to replace it with var. And again, if you have to use annotations, then you have to have a type, and you will probably replace the longer name with var and use the annotation. This was the main idea of having this var word also available for the parameters of the lambda expressions. But again, 99% of the cases you will probably see either this one, In practical scenarios, all of them are really important, and there is equal chance to find them in questions of your OCP 11 exam, so learn them, they are important. If this is clear, then the next thing, of course, that we would like to discuss will be what happens on the right side of the arrows. So let's create a third example for that. So I will create example 3. And in example 3, I will just write another interface called Z, and I will make it return something this time. So let's make it an M, and now I will just leave it without parameters because I don't care anymore about the left side. Now you only focus on the right side, and then you can just take this as independent. So look always at the left side and at the right side of the lambda expression and take them as being independent. We don't have to explicitly make here all the combinations because it will take a lot of time and you will see nothing new. So now I will continue on discussing only on the right side of the expression, and I won't focus anymore. All the possibilities that we have already discussed about parameters will still be available for any of the cases that I discussed for the right side of the expression. So let's create the example 3 function. And here we can have something like this. Of course, round parentheses, nothing between them because the method has no parameters. And then if it returns something, we can directly write something like this, the value, or call a method that returns the same type. So you can have value 5, for example. So another option would be, let's assume that here we have a method static void, static int, and it returns something. Then I can just call it here. So you can have call of a code that returns the type needed or directly the value that is needed. And another option would be, and you have to be very careful with this, you can use the return word, but when you are using the return word, always this happens only between the curly braces. So you can write something like this. So this is a block of code, and of course here then it means basically that you can write something else as well. So you can just write something like int e, you do something and then you return. In terms of clean coding, it's not okay. I wouldn't recommend you to do something like this. So lambda expressions with curly braces are to avoid. You will find this in the questions of the exam. Avoid this kind of situations by creating separate methods that you call, like in my second example here. In practical scenarios, avoid using the curly braces, as you will see when we will discuss about nested types. One of the reasons for why you write lambda expressions is to make the to write simpler an anonymous type and to avoid writing a lot of curly braces and round parentheses. So you just take everything from lambda expression if you avoid writing the curly braces. Of course, you still need to know all the syntaxes for your OCP 11 exam, but in practice, try to avoid writing the curly braces. For the OCP 11 exam, remember that you can't use the return in this syntax. This doesn't compile, as you see. So I can't use the return word when I don't have the curly braces. If I don't have the curly braces, I only write the call to the method or directly the value that has to be returned. I don't have to specify, and I can't correctly specify the return word. The other way around, if I use the curly braces, then I have to use the return to specify that I return the value, and when I return the value, you can just see these curly braces exactly as the normal block of a method. So just see this as the normal block of a method where you have to use return to return a value out of the method. So this is how it's working. Of course, using the curly braces, that allows you to have more than one operation. So if you don't have curly braces, then you can't do multiple things. I can't do here, for example, two syntaxes. Why we should use lambda for calling another method when you can initialize variable using method call? Okay, I'm not sure if I understand. If you here refer to this operator, then I will just take it in one of my next examples. So is q no okay, I understand now. I understand now the question. So you can't write, actually what you are writing there is not correct. You can't write something like this. So see that the difference is here that this method returns an int. So you can't write something like z4 is q directly, because here it's a z object. So what happens here is that when you write something like this, actually in z you have this object that has the method defined inside, which is called m, and then you can call it from there. So you would do something like this, and this call of m would actually return your value. So you can't simply just write z4 is q. This is the difference. Okay, so what we do now here is not calling here. You don't actually call it when I do something like this. If I'm running this main method now, it won't display any value. It won't use any value. It will only do that if I really call the method inside, which is the m method, and this m method then will basically return my value, which in this case, if it's z4, it's the value returned by q. And you can do this also. Let's do a system out of y here, and you can put a breakpoint here. So, and the breakpoint here maybe is also good. It doesn't allow me to use the breakpoint because it's only a declaration. So if I only have a declaration, it will not allow me to use the breakpoint, but I can do something like this. I use a system out here, and then I put a breakpoint on the system out call, and then I will just use the debugger to see what happens. So Razvan, what if there are multiple methods with the same signature? If you refer multiple methods in the same in the Z interface, then you can't have, because being functional, you have to have one abstract method and only one. That's the rule of the functional interfaces. So you can't have multiple, and in this case that's the only way it works. If you would try to add here one more method, then you have a compilation error and you can't have the lambda expression. So I will come back to having multiple methods with the same signature immediately after I do this debugging to show you. So if you go to the console here now, you see there is absolutely nothing, and if I do a step over here, I'm now calling the method. So only after calling the method you will actually go here inside the queue. So if it did first stop here on the first breakpoint, so this didn't call the queue method, because if it would have called the queue method, then that means that I would have been in this breakpoint as well, but this didn't happen. So now if I'm going one step further, only now when I call the m method, I'm actually entering the q method. So the call of q was not done here, but it was actually done here. This is only a definition of the m method. So this is how we override the m method. It doesn't call q here, but then when you call m, it does exactly what you have set here in the right side of the arrow. So it calls q, and then of course further you will have your system out with the value in the console. So this is how Lambda works. And regarding multiple methods, I'm going back to the first example. So in the first example here, you remember that I said if you don't have only one method, then it can't be a functional interface. So for example, if you do something like this, you have two methods, then it's not a functional interface anymore. Even if you don't use the functional interface annotation, then it will not compile anymore here. So you will never get into a situation in which you have multiple functions with the same signature, just because you can only have one function that is abstract. And if you don't have one function that is abstract, then you don't have a Lambda expression. This is how Lambda expressions work in Java. So there is no chance of getting into the situation in which you have multiple methods that return the same type. Okay, So this is what you can do from the right side. Again, to remember, return only with the curly braces. If you don't have curly braces, you don't have return. And in order to have multiple instructions, then you have to use the curly braces, and do that only with exercises or OCP 11 questions. Don't do this in practice. Avoid using curly braces because you want your syntax to be readable and the most simplest as possible. Okay, this is basically what you need to know for writing lambda expressions. So this is generally represent all the rules that are important regarding the syntaxes of the lambda expressions in terms of your OCP exam. If again we discuss only about practical scenarios, remember only to use the simpler solutions. So like this one, in this case, this one makes your code much more readable, or this one, for example, if you would like to do something. Always the simplest way of writing is the best and the most readable. Okay, so this is it with the lambda expression. Fortunately, it wasn't that difficult, but we will have to discuss in terms of lambda expressions at some point also the syntaxes of interfaces that already define functional interfaces in the package Java util function. So I won't do this now. I only planned for today the syntaxes of the lambda expression in Java, but in one of the future lessons we will see that there exist multiple already defined functional interfaces in Java, and you don't have to basically write them. If you have the same signature, you can use a predefined interface from the Java util function, and I will show you one example to be clear with what I mean, but I will take all of them. There are 9 basics interfaces and about 30 something to 40 in total in that package that we will discuss. But to be sure that I made myself clear what I want to say, and I will create an example for class here, is that if you want to have a mathematical function which usually looks like this, x is turned to a y, like in case of an encoding. In case of an encoding, you can say I want to encode ABCD into its reversed, which is DCBA. So this is a mathematical function, and if you want to implement this operation, of course, if you want to write it as a lambda expression, you need an interface for it. So you can choose to write your own interface. Just, I don't know, create here an interface that you call reverse, and you have your method string, and you receive a string and you output another string. So this is the input and you have the output. And then of course you can do it with reverse. You say reverse r is, and then you have x into new string builder. Okay, and this way I've made use of the string builder class that we will discuss in one of the future lessons, so don't worry, this is just reversing the string. If you would call something like this, now string y is r1 abcd, and you output y, then this will print out in the console the reverse. So basically what this is doing is calling the reverse method of this object, which is exactly what I've written here on the right side of the lambda function, and that again this is basically doing is reversing the string. So you will see the string as is written from right to left instead of left to right. So that's ABCD will be turned to DCBA. So you can just run it and you will see the result. But again, if this is your case, then you will see that Java is smart enough to already declare in the JDK some interfaces that represent the basic contracts for you used with Lambda functions, and this is basically a mathematical function, and the mathematical function is represented by an interface called function, which is predictable. So I could have written the same thing like function, and here I will have to write some generic types that we didn't discuss, but again, don't mind them, because that's why we are not doing these interfaces in detail now, and that's why we will do this in one of the future lessons, just to show you that actually what I'm using here is I have exactly the same implementation, so I can copy paste everything that's after the equal sign, and what I do is I'm using now something that already exists in Java. You can see that it was automatically imported by my IntelliJ from a package from Java util function. So in some cases you don't have to just rewrite some of the contracts because they already exist. And in one of the future lessons, when we have enough knowledge, for example, one of the reasons for why I'm not doing this now is that you would need to know first what generic types are, and we didn't discuss this. But in one of the future lessons, we will discuss about some of these important interfaces. You have their function, and we have predicate, consumer, by consumer, and so on. So there are 9 interfaces basic, and about almost 14 total that we will need to discuss. And knowing them and discussing them will allow you to know when you have to write your own interface and when you don't have to write your own interface, because now using this you can basically do the same thing by using a type that we didn't define, and of course it has a different name for the method, but it will work the same, and I didn't have to write this like I did for this one. So this is what we will discuss. Okay, and this is everything that I want for the moment to tell you about the syntaxes of the Lambda expressions. So let's go to the next subject plan for today, and this is the enum structure in Java. And by knowing also the enum, we can mark as completed all the structures that the language offers us. So we have discussed about classes, abstract classes, final classes, interfaces, including the syntaxes of the Lambda expressions, and now we are discussing about the last kind of structure that we can use in Java, which is the enum. Enums are not part of the OCP 11 exam 1, or how it was called in version 8, the OCA exam. Enums are part of the second exam, but I will do them now because from my point of view it's better that you have first an overview of all the structures in the language. So I would prefer to just introduce you to the enums now. You will anyway have to learn them at some point, so even if we wouldn't do that now, you would need to know them. It's better if we just cover everything that the language offers us from the beginning. So that's why I prefer to end with all the structures and consider starting with the next lesson that you know everything that Java offers you from this point of view. So let's create example 5 here, and in the example 5 I will show you how an enum looks like. And the enum is again has its own keyword, so you can create an enum by using the enum keyword. And what this basically is, you can just imagine it as being a class that defines from the beginning a number of instances that you can use, and you cannot create some other instances of that class. So here with an enum you always start with enumerating the instances of this type. So in my case I can say that I have 3 types of coffee, like small, medium and big. And here I will put it in a comment afterwards. If I were to define the same thing with a class, then it would look something like this. I would have written public final class coffee. Then always the constructor of an enum is private, so the enum, exactly as a normal class, has a constructor and has a default one, but it is always private. You can't define constructors with other access type in enums than private. And what small, medium and big are, they are actually public, static and final instances of the same type. So it would look something like this. And they are by default created by calling the default constructor. So that would be small, medium and big. So this is your enum. In fact, instead of writing it like this, you just write it much more shortly like this. But it's important to be mentioned that small, medium and big are not some kind of primitives or just strings. They are not strings, they are not primitives, they are instances of object. Which kind of object? The one defined by the coffee, which you can see as just a normal class. So of course I will have to comment this out because I cannot work with both of them in the same file. But I want it to remain here so that you can compare it and understand what actually means when you just write small, medium and big inside the enum here. It basically means that you declare a public static final variable of the type default instantiated by calling the default constructor. So you might avoid writing this semicolon here. This is only mandatory if you are writing something after the enumeration of the instances of your structure. So you can have something else, and even if in practical cases you will basically more or less see enums used like this, you have to know that the enum is in general just like a normal class, Final, I've added final here because you can't inherit from an enum. You cannot extend an enum, so that's why it's more like a final class. The enums are by default final, so you cannot extend them, but they are just like normal classes, and these are just like normal instances. The difference between an enum and the class is that you always have a constructor which can only be private, and you will never be able to just instantiate enums with the new operator. You can say new coffee if it is an enum. But if you want, you can just end this with a semicolon. This is the enumeration of the instances, always as a first instruction. So this is always first in an enum. This is a syntactic rule. If you try to put it after some other instruction, it will not compile. So it's important to remember that it's always first. And if you want, for example, you can redeclare the constructor to do something. You can even have multiple constructors using typical normal overloading. Let's assume you have also quantity here. You can have attributes. Of the object like you have in a class. So very, very similar to a class. You can write here code very similar as you are writing it in a class. You can have getters and setters. So you can see that an enum is not necessarily just an enumeration of values as we tend to understand it. The enum is basically a class, and you have to see it as a prototype of an object. Again, the main difference being that with enums, you just define from the beginning some instances, and you can only use those. You can't create other instances afterwards. You see, I can create constructors, and if you are trying, this is private by default, so private by default. If you are trying to make it some other than private, so if you try to add a public just before it, of course it won't compile. You can explicitly put a private there, but this is redundant, because anyway it is private. If you specify, or if you don't specify it, the constructors of an enum are always private, so you don't have to put a private there. Even if it's not there, it is private, like very similar with how we having the methods in an interface. If you don't specify the public before a method in an interface, it's still public. Here with the constructors of the enum is the same. If you don't put the private, it's still private. You can't put public. If you put public, it's a compilation error. So you might find, for example, something like this in case of a question of your OCP 11 exam, and if you see something like this, then you have to know that a constructor of an enum cannot be public. So this is a compilation error. And now you can basically use this as normal objects. So I can just go and create here example 5, and I say coffee is, I cannot create instances. This is not possible. I can't write something like this, because being an enum, this is private in the enum. So my only choice would be to call one of the values of the enum, big, small, or medium. And due to the fact that you know from my previous explanation that these are static objects, that means that you can just refer them from the type directly using the dot operator, so coffee.medium. And you can see, you can just now use, I don't know, set quantity. Just use it as any normal instance of an object, so just like any other instance of a normal class. But I couldn't create it. I have to use one that already exists. That's the difference from a normal class. But it's just like a normal instance on which you can now call methods like getters, setters, other methods that you define inside. It's your choice. Maybe you are wondering now, okay, I can create some different constructors like I did in my case. I can have multiple constructors. Basically, as in any other class, I can have as many as I want, as long as I respect the overloading rules. But you can see that this one is never used, and even my IntelliJ offers me the hint that this is never used. And how can I use it if I can't call it from outside? How do I use it to create the instances? So in the case of the enumerations, you have this different syntax in which to call a constructor, you can only do that from the enumeration itself of the instances. But then after the name of the instance, you just open around parentheses and provide the values for the parameters. And now what happens is that this small is created using the second constructor. Okay, very good question, Ionut. So this is exactly what I was now trying to explain. So you can have indeed multiple constructors, and you can't call them from outside, but you can call them from the enumeration itself. So you can see here medium and big in my case are by default, because I didn't specify any parentheses after, created with the default constructor. So yeah, and here is the way to use the second one. So you can use the second constructor, and this is the syntax. I would like to tell you again that this is really theoretical concepts that you will most probably see only in the OCP exam questions. That is, in practice, you will 90% of the cases, or even more, use the enumeration only to specify some values that you use afterwards. You won't even have a lot of cases in which you have attributes, constructors, or methods in the enumeration. So everything that I tell you, all these details that I am providing you now, are generally referring to the OCP 11 exam, because in practice you will just use this only for the enumeration itself. Okay, let's see some other things that you can do, and you have to know. It is important to know about enumerations that this is the only object type created by you that can be used with a switch expression. So, for example, in my case here, I can say coffee medium, and then I can have a switch on C1. And then I can have my cases here. Small, and the others, doesn't matter, you can have all of your cases here. Yeah, I won't spare time doing more than this. The important thing is that you can use, and an enum can be used in a switch. So in a switch you can use any int or value that can be promoted to an int, like byte or short. You can have chars, you can have strings, and you can have any enum value, like I do in my case. So maybe even when we started with the enum in the first lesson, with the situation in one of the first lessons, I have told you that you can use enums in switch. At that time I couldn't offer you an example with that because we didn't know what enums are, but now you can see that they can be used with the switch as well as you have used integers, chars, or strings. And this is practically the only object type created by you that can be used in the switch expression. Another important thing to be remembered about enums is that by default each of the value has a name and an ordinal. So what is the name and what is the ordinal? The ordinal is a value that indexes the is a value that indexes each of the values of the enumeration. So each of the values are identified by an integer, like very similar to the array starting from 0. So small has the ordinal 0, medium has the ordinal 1, big has the ordinal 2, and so on. If you would have more, each of them is indexed with an ordinal, and you can find the ordinal of a value by calling this ordinal method of the value itself. So for example, medium here will be 1 because small was 0 and medium is 1. So if you would print it out in the console, you would see that this displays 1. And let's take also the name. The name is exactly the name of the value itself. So in this case is medium as a string. So exactly how the way you named the identifier will automatically become the name of the value. So if you print the name here, like name space and ordinal, then you will see in the console medium space 1. Let's run this and see. Again, important for your OCP exam, I would recommend to remember this as well, because you will find this being used with JPA implementations like Hibernate. That's one of the places where you will find the ordinal and the name of a value of an enumeration being used. It is the way a JPA implementation like Hibernate or Eclipse Link stores an enum in the database. So you have two options, by storing it by name or by ordinal. This is of course another discussion, but is one of the good points to why you should remember that value of an enum has an ordinal and a name, because you will find it also in practical cases, not only in questions of your OCP 11 exam. Of course, there will be also questions in the OCP 11 exam about this. And the last thing regarding the enums that I would like to tell you is that you can very easily parse the values of an enumeration with a normal for, and you can do like this. For example, coffee from coffee, and it has this very nice values method which returns an array of coffee. So this values method is basically providing you an array of all the values inside the coffee enumeration. So that's why you can very easily now parse them like this. So if you want to simply print out in the console the names for all the values in this enumeration, you can do it like this. You just parse it, you take all the values as an array with the values method, which is static, and you call it directly from the enumeration. So this provides you an array in the right side of the column operator in the for, and then the for will basically take all the values, and you can do whatever you want with them in the curly braces of the for. Like in my case, I just print them in the console. So if I run this, then I should be able to see a small, medium, and big, which are the values in my case. Yeah, this is small, medium, and big. I said the last thing, but I still have one more just to finish completely. It's a really I would say not important in case of practical scenarios, but I have seen this in one of the exams in one of the OCP exams, so I would like to make you attentive on that. Let me create for that another example package, and this is the last one, and with this example I will finish completely, I promise. If you have an enumeration like for example seasons, and you have this spring, summer, and this is of course an enum, and winter. Okay, you can have the very strange situation in which you want to override the method from only one of the values, and that means you have a method here, and in this case I would like to be a non-abstract one, so I will just make it like this. If you want to override this and do something else, like for one of the seasons, you have this syntax in which you open the curly braces here, and then what you can do inside the curly braces is you can basically override the method, and I can even use the override annotation here to show you that this is really overriding the method in the enum. So it's a very ugly syntax. In my point of view, it is only theoretical, and you will probably never see it in a practical scenario, but I have seen this in one of the OCP exams, and what I have seen also in the OCP exam, and that's my final example, is to have even an abstract method in an enum. This is possible. Just mind that if it is abstract, then you really have to do this overriding for all of the types, so all of them, like I do in my case. So if you do it for all of the cases here by opening the curly braces for all the values and overriding, you see that in the end this will compile, and you can even have abstract method in enums. Again, constructors are used internally in the enum. Yes, if that is a question, I'm not sure if it is a question, but if it is a question, yes, the constructors are used internally in the enums. So you have here, like I said in my case, coffee. This is by default private. Again, I'm coming back to the example to prove it. And you can't have anything else. If you try to make it public, it doesn't work. And by default, when you write the value of the enum, like medium and big, then it's using the default constructor, but you can call one of the others. With this syntax, you just add the round parentheses after the value, and then you call, in my case, I call the one having the int quantity as a parameter here. You can call one of the others. So in enum, you can have values that take no parameter, one parameter, and more than one parameter. I'm not sure what do you mean by values that take parameters, because here be attentive that if this is what you mean by values, here what you have after the value is the call of the constructor. If you want to have 3 or more, yes, you can have more, so you can have as many as you want. For example, I can just make one here with a string as a parameter, and let's say that we want to just print it out in the console. So you can still have medium that uses the default one. You have small that uses the second one, and then big now here uses the third one. So you can have something like this if you want. Of course, you can have as many constructors as you would like to have here. So you can even, if you want, call exactly as we are doing from the classes. You can use this with round parentheses from one constructor to call the other. So all these rules that apply, and we have discussed them for classes, they still apply for enums. The only difference is that constructors in enums are private. You can't make them otherwise, and you can only call them when creating the instances of the enum. That's in as the first instruction here. Again, this is always the first instruction in an enum, and you can specify which of the constructors you are calling just by using the round parentheses after them. Oh, okay, I understand. So yeah, I was also I thought you are asking a question. That's why I was coming back. So you can ask questions. When I see something in the live chat, I'm trying to answer your question, and you can let me know if you did understand or not. So so yes, I'm also trying to answer the questions in the live chat, and let me know if it's clear. If it's not clear, I'm always coming back and explain them again. You can also answer to the questions if you want. That's really good practice, because this way we will have a good communication and a good discussion here. So that's why we have a live event. So thank you very much for your attention, and I'm really happy to see that it's a lot of you discussing here and trying to help with answers and questions and everything. So I think by this I have basically managed to show you. I've shown you even the part with the abstract, and more than this for the moment it's not really important. So we have really covered everything that I wanted to cover in this lesson about the syntaxes of the Lambda expressions and the enums. It's not the last time you will see them, of course. The fun just begins now, and in the next lessons we will use all the things that we already did use until now. And of course that is we will try to use them with examples and with other new things that we have to learn, both for practical scenarios as well as for the OCP 11 exam. So if there are no other questions, again, I'm really happy to see a lot of you and writing questions and answers in the live chat. I hope there will be more and more with the next events. Don't forget that we have other events also for JPA, and I will add more streams when I finish with this one. So there will always be on this channel live events to which you can participate. And thank you also for your attention, and hope to see you in the next videos as well. You will have the code also available on GitHub after I finish the live stream. Thank you again, and have a great evening.